Happy Wednesday, sixth graders. Okay, so here's our agenda for today. We're going to review what we've discovered so far about the cup systems, and then we're going to do a quick review of how molecules behave in solid, liquids, and gases, because we're going to need that going forward. So our target for today is I can model molecules in solid, liquids, and gases. We've done this before, but we just want to make sure everybody's at a 4 for this target. So let's go ahead and get started with a review of what we've discovered so far. So we've discovered hot liquids in cups, they cool down over time. Cold liquids in cups heat up over time. And this happens even when cups are completely sealed to the outside. And heat is somehow leaving or entering the cups, but we don't really know how yet because heat doesn't have mass, so it's not matter. We haven't really discovered what heat is yet, but we know that somehow it's either entering or leaving the cups. And sometimes liquids evaporate and sometimes gases condense. We don't really know why yet, but we know that that happens. So the questions that we're going to be answering over the next 2 weeks or so is why does this happen? Why do liquids cool down and heat up? How does it happen? And how can we design a cup that's better at keeping liquids hot or cold? All right, so let's review solids, liquids, and gases a little bit. This is going to be a student reading that we'll do together. If you would like to refer to this reading later, it's in the Wednesday folder. You're welcome to open it and read it on your own, but right now we're going to read it together. Okay. So here's the student reading. Chemistry is the study of matter. You could say that chemistry is the science that studies all the stuff in the entire world. A more scientific term for stuff is matter. So chemistry is the study of matter. Matter is all the physical things in the universe, all the stars in the galaxies, the sun and planets in our solar system, the earth, and everything on it and in it are matter. Matter is defined as anything that has mass and volume, which means that it takes up space. All human-made objects, all organisms, the gases in the atmosphere, and anything else that has mass and takes up space, including you, are examples of matter. Chemistry is special because it looks at matter all the way down to its smallest parts, the atoms and molecules that matter is made of. To give you an idea of how small atoms and molecules are, use the metric ruler to look at the length of 1 millimeter. It's about the size of a dash like this one. Try drawing a tiny line or dot that is about 1/10 as long as the dash. It might be about the size of the period like the one at the end of this sentence. A hydrogen atom is about 1/10,000,000th the size of a period. So it would take 10 million hydrogen atoms lined up next to each other to go from one side of the period to another. Here's another way to imagine how small atoms and molecules are. In about 1 tablespoon of water, there are about 600 billion trillion water molecules. That's 600 billion trillion. This number is so huge that even if you could count 1 million molecules every second, it would take you about 200 million centuries, or about 20 billion years to count all the molecules in a tablespoon of water. Having a better idea of what atoms and molecules are and how they interact can help you better understand the world around you. Matter is made of atoms and molecules. We have already used the term atom and molecules a couple of times. You will learn more about atoms and molecules in 8th grade. For now, let's say that atoms and molecules are extremely tiny particles that make up all the matter on Earth. An atom is a basic building block of all matter. A molecule is made of 2 or more atoms connected or bonded together. Even though atoms and molecules are not the same, the model we are using shows both atoms and molecules as little circles or spheres. This model makes it easier to show some of the basic characteristics of the different states of matter on Earth. Matter, solid, liquid, gas. On Earth, matter is either found as a solid, liquid, or gas. A particular solid, liquid, or gas might be made up of individual atoms or molecules. Here's a simplified model of the three different substances. One is a solid, another is a liquid, and the other is gas. In the models we use, the little motion lines or arrows show that the particles, atoms and molecules, that make up the solid, liquid, and gas are moving. As you look at these models, think about these two big ideas, which are always true when talking about matter. Matter, solid, liquid, or gas, is made up of tiny particles called atoms and molecules. The atoms or molecules that make up matter are always in motion. These first two ideas make up a very important theory called the kinetic molecular theory of matter. Another big idea is the atoms or molecules that make up a solid, liquid, or gas are attracted to one another. In a solid, the atoms are very attracted to one another. Because of this strong attraction, the atoms are held tightly together. The attractions are strong enough that the atoms can only vibrate where they are. They cannot move past one another. This is why a solid keeps its shape. In a liquid, the molecules are also in motion. The attractions between the molecules in liquids are strong enough to keep the molecules close to each other, but not in a fixed position. Although the molecules stay very near one another, the attractions allow the molecules of the liquid to move past one another. This is why a liquid can easily change its shape. In a gas, the molecules are also moving. The attraction between the molecules of a gas are too weak to bring the molecules together. This is why gas molecules barely interact with one another and are very far apart compared to the molecules of liquids and solids. A gas will spread out evenly to fill any container. When looking at the different states of matter, it's kind of like a competition between the attraction the molecules have for each other compared to the motion of their molecules. The attractions tend to keep the atoms or molecules together, while the motion tends to make the atoms or molecules come apart. Here's a chart that shows the attractions and movements in the different types of matter. In a solid, the atoms or molecules are very attracted to one another, whereas a liquid, they are somewhat attracted to one another, and in a gas, they are barely attracted to one another. In a solid, the molecules and atoms vibrate but do not move past each other. In a liquid, they vibrate but they're also able to move past one another. And in a gas, they vibrate and move freely past one another. Solids have a definite shape and volume. Liquids have a volume, but they do not have a finite shape. And gases do not have a finite shape or volume. They'll fill the container they're put in. So let's take what we know about solid, liquids, and gases and make a model of our cup system. So A represents the walls of the cup, and we know that the walls of the cup are a solid. So let's look at how these solid molecules move. If we see they're fixed in their place, but they vibrate a lot, although they're not able to move freely. They're very attracted to each other, and those intermolecular forces hold those molecules tight into place. So here's how we would model those molecules. The walls of the cup are a solid, so that we would arrange our molecules in a pattern, because solids are arranged in a pattern. And we'd put the motion arrows around them to show that they're vibrating in place and not moving. So now let's look at B. B represents the liquid in our cup. And particles in a liquid, they are able to move around. They are still attracted to each other. They're still close together, but they're able to kind of move freely past one another. The intermolecular forces are not as strong as they are in a solid. So here's how we could model those molecules in the liquid. We could use the arrows to show they're moving in random directions. and that they're able to move freely past each other, but not organized in any sort of a pattern. So now let's take a look at C, which would be the air or the gases that are in our cup. Even if we were to seal our cup, there would still be air or gases in there. So gas molecules, their intermolecular forces are nearly non-existent, extremely weak. So when we look at them, they're not attracted to each other. They don't stay near each other. They move a lot faster, and they're much, much more spaced out. So we could model those molecules like so. Now the cup is going to have a couple different types of gas molecules in it. It will have the air, and then it will also have the water that's turned into water vapor, if we remember from evaporation. So this could be how we could model those gas molecules. They're further apart, they're spaced out, and they're moving faster than in the liquid. Here's your task for today. You've already completed this ed puzzle. Now what you need to do is open up task number 2 and answer the questions. If you would like to read that student reading on your own that we just did together, it's attached in the Wednesday folder under task number 2. So let's just do a check for understanding. We've touched on this target several times, but let's kind of take a moment and kind of think of where you are on this target. Can you model molecules in solid, liquids, and gases? Can you model their spacing, their movement, and talk about the attractions that they have to one another? If you can, then you're a 4. All right, have a wonderful Wednesday. Don't forget to complete task number 2.